It's a great pleasure and an honor to be here today. And I'll just take my 20 minutes to sort of, to use a metaphor, carry coals to Newcastle. I'm talking to a set of people who know everything about AI, and it's a bit presumptuous of me to say what AI is about and how it can be applied. But sometimes it's useful to get a perspective laterally, and it's very useful certainly for me to learn. So let's start from somewhat of a strange beginning for this audience. What is artificial intelligence? And Alan Turing asked in his famous paper in 1950 called Computing Machinery and Intelligence, he asked this question. And that's a very beautiful paper. It's got 2 or 3 pages, couple of references, and it's actually amazingly understandable by anyone reading it today. So it's a beautiful paper. And he answered this question, can machines think, in the affirmative. And he pointed out that artificial intelligence, as it's now known, aims to simulate human intelligence or replicate it in machines. Now, the problem is, when you answer this question, there are multiple ways by which we can start framing this. And some eminent scholars, Stuart Russell and Peter Norvig, say it's about thinking humanly, thinking rationally, acting humanly, and acting rationally. And these are important for the topics which we are looking at today. However, much of what we talk about as AI today is actually what is called narrow AI or weak AI. And this kind of AI operates with a very, very limited context and is not a full simulation of human intelligence, but of a very narrow utilitarian aspect. It's focused on performing some task really well, and these machines may seem intelligent. They're operating under extraordinary constraints than even the most basic human intelligence. Now, narrow AI is all around us, and actually in nature, you see that really well. If you walk around the woods near Bangalore, you will see enormous termite hills. And these are really exquisitely built and constructed. But no termite has an overall view of what's happening, but yet this complex structure is built. And this is what happens in nature, and this is what computers are doing now in multiple different ways. Now, much of narrow AI, of course, as you all know, is powered by machine learning and deep learning. And therefore, it's important to understand the difference between these terms. And venture capitalist Frank Chen provides a good overview on how to distinguish between them. And he says that artificial intelligence is a set of algorithms and intelligence trying to mimic human intelligence. Machine learning is one of them, and deep learning is one of those machine learning techniques. In other words, simply put, machine learning feeds a computer data and uses statistical techniques to help it learn how to progressively get better at the task without having been specifically programmed for that task, eliminating the need for millions of lines of written code. So machine learning consists of both supervised learning using labeled data, and importantly in our context, unsupervised learning using unlabeled data sets. And deep learning is a type of machine learning that runs inputs through a biologically inspired neural network architecture. Now, given all of this, where do we go in terms of artificial intelligence? So we should leave aside the public conversation about artificial general intelligence, because all said and done, that seems a long way away. And we should take forward the applications of artificial intelligence in the context of machine learning and deep learning, which has gone forth enormously well. For that, data is the material for artificial intelligence or for machine learning and deep learning. But the metaphors of data being fodder or oil are valuable but somewhat misplaced. We know what we can do with oil and with fodder, but raw data is not useful in any way in most people. So in other words, data is not information. What makes data valuable? Data is a jumble of raw facts, and users need to sift through it to properly interpret. And only then does data become useful. And therefore, annotating data or having ways of annotating unannotated data on large scale is very important. So that would convert data to information. But yet, information is also not knowledge. Information, in contrast, is a collection of organized and structured facts. Users invest less time and energy finding these facts, but still, it's more valuable than raw data, but not enough. We need to convert information to knowledge. And that is a big challenge which we have. And that requires, now we're going away from just computer science and mathematics and statistics to understanding context in a wide variety of areas. Knowledge is therefore very important, and that kind of a training starts bringing in human interfaces on scale. Our knowledge, our cultural and institutional memory is very, very important. But knowledge is the application of information to answer a question or solve a problem, and therefore it brings in a context. But even so, knowledge itself is not enough. Knowledge also requires understanding to make decisions. And one of my favorite examples is that of Jocelyn Bell, a famous astronomer now, but as a graduate student, she was studying, looking at data coming in from all over the universe, and she made a prediction about the presence of pulsars. Most other people and most computers of that time or now would say that this is very likely noise. But because she had information going to data, and because she had knowledge, and because she had understanding, she could make that leap and say, look, this is something important, and this is pulsar. So therefore, our human connection to AI in general, as we call it today, is going to be very, very important. Now, data comes from diverse sources. And of course, there are traditional relational databases where the data comes from. And there's also machine-generated and real-time data, such as from all the devices which we're putting on. So data mining tools scrape websites. Machines also generate data in terms of log files. And we have big enterprises such as CERN in Geneva, which also generate huge data. Telescopes looks at the world. So enormous amount of data is available. Now, data and this analysis from information to decision-making, all of that leads to a certain hubris that somehow merely analyzing data can lead us to extraordinary conclusions. That cannot be further from the truth. We need a way by which this analysis of data is combined with human interactions now for public good. Now, I'd like to end here by pointing out how this can be done. The use of big data in multiple areas, such as health, agriculture, society, and so on, is very important. But this requires deep training of people to appreciate the value of big data, not be contemptuous of it, yet not leave the decision-making to data and assume that just the analysis of data in some magical way is going to tell you what is right and what is wrong. So this human interface, there are many examples in our recent history where not paying attention to that human interface has caused problems, but paying attention can allow decisions to be made in a go, no-go manner. The last point I'd like to make is about data and knowledge and AI and power. Historically, right through human civilization, those who have knowledge wield power. And today, those who have access to the tools of AI wield disproportionate power. And therefore, we have a huge challenge as machine learning and deep learning get better. Machines will be able to advise us better and better on what we do, genuinely. But it also means we are more and more disempowered. If this is going to be the situation for those who are well-to-do, imagine how it's going to be for those who are not well-to-do. And therefore, the most critical challenge we have in India today, if AI has to work for society, is education and training at every level so that people, our citizens across the spectrum, not only have access to the decisions made by the analysis of data, but have become reasonably good at the tools and their understanding themselves. So they are empowered to decide which of the kinds of data streams coming into them are useful or not. In other words, a farmer not only needs to know from data what is good and what is bad, but understand why that is good, why that is bad. In other words, a feedback mechanism of connection of research and a demand for research and an understanding of research by all people is necessary. And the spread of the footprint of science and technology and understanding and reasoning in a large country like ours with a young demography is the only way. Thank you very much.